Video. We're going to try to put the SERV RISC-V uh, CPU onto the BeagleV Fire. Here's the steps. Here's some resources. Uh, Here's the documentation that we're going to be following. It's quite good. I don't know if you can read that or not. There it is. Go down to the BeagleV Fire. Click on that. Go down to demos. Click on that. Go down to customize BeagleV Fire, which is also here using Verilog. Click on that. And this is the documentation. It's pretty good. Um, let's see other resources. So the SERV CPU is here on GitHub. There's also a package manager for FPGAs. It's here at Fuse SoC. Here's a script that I wrote, SERV auto setup, which deals with all the package manager stuff. There's quite a few steps, as you can see, going back to SERV. There's a lot of steps that you go through. It's not too bad, but this script goes through it for you. If you're interested, I also have some iVerilog examples, some GHDL examples, some Polar Fire Icicle stuff. I have a lot of that also on my YouTube channel. Um, let's see. And now we're going over to the Beagle vFire's GitLab page. And so this is the main example template page. And so we go to Beagle vFire as the user, go down to Gateware, left click on it, brings you to here, go over to Fork, left click on it, brings you to here, and then put in a name. So SERV on Fire. I like that name. And so select a name here, and the only option it gives us is me. Give it a name here. I mean a document here. SERV risk V on um, Beagle V Fire Polar Fire SoC Gateware. Nice. And then click on Fork Project, left click. And with any luck, it will take you to your page with your repo. And it worked fine for me. If it doesn't work for you, it's probably because this is the first time you have forked a project and you need to get access. So to request access, go to the forum, and there's probably a link down here somewhere on the side. Yeah, requesting access to GitLab to fork Gateware. And just, go down into there and you ask, please, they say, okay, here, please enable me to fork. That's me. And then the Beagle team got back to me, enabled, very quick, and same day. And then I said, thank you, because it worked just fine. And so that's that. We'll talk about this in a moment. And I think we're ready to actually start doing something. So let's get back to, see, we've actually done the fork already, have we? Yeah, my goodness. So let's go in and click on the code. Pick SSH or HTTPS. Control C. I do my work on Ubuntu 2204, and I'm in a VirtualBox VM. So I'm going to do a git clone, paste, turn, and then I'm going to go down into Gateware here, S. so you can see what's in the directory. Now I want to git clone my script that sets up the serve processor's workspace. Git clone https:// github.com/busted1/serve auto setup. I think that's right. Oh, great. And now then we're going to cd down into serve auto setup. WD, this is where we are, ls, this is it. So we have a script that creates a workspace for the serve processor. That's where you can do some simulations and things like that. It's the workspace allows you to build almost any FPGA that they've supported. BeagleV Fire is a place where we have some scripts. Let's just do a quick look at that. So we have a build script, which we'll run in a moment, and a couple of files that we end up copying over so that we don't have to edit those two files all the time. So let's go down and let's run serve create sh. Bonk. What we need to do is we need to source serve create sh. This script creates a couple of environment variables. And if you want to get those out of the script and into your shell, um, you need to do a source. Or I think you can also do a dot. Now we're running that all nicely, and the script dumps you down into the workspace. And now what we're going to do is ls / we're going to run we're going to run this build script. And if we do a cat of it, just so we know what we're doing, or try have the illusion of knowing what we're doing, a lot of the steps comes right out of the BeagleV Fire or user guide steps. Is that we're going to convert Verilog tutorial to my serve cape in the YAML file, and then we're going to copy Verilog template to my serve cape, and then we're going to edit, or in this case copy, but in reality usually you edit the add cape tickle to add the files that we're going to be adding, the Verilog files from serve into the project. So if let's do a compare just to see what's getting added. So I like the program Meld to do compares. On Ubuntu, it's just a sudo apt-get to bring it in. And so let's go in and compare this with this. And since I haven't run the script yet, my serve cape doesn't exist yet, but we can still look at what's going to be there in Verilog template. Hit return, and here's Meld for you. And so we went from Verilog template to my serve cape. So, and then you can see all the way through here, we've changed all these Verilog templates to my serve cape. And then we added these new lines. And so these are new lines that basically are the serve RTL, HDL files. Yeah, so I think that's it. From here, you can see that the meld goes and it highlights, and over on the very far left where there's changes, if there's new stuff, it showed in green. So that's what we changed in this file. Working down through, we're going to replace Verilog cape with my SERV cape in the device tree, and we're going to edit cape and change it, and so that's instantiating the serve uh, the serve processor into the cape. And if we just do another meld to see what we did differently, to see what we had to change, again, we go back to Verilog template, return. Okay, and you can see it's very light, but we got a green section here, a blue section here where we changed and modified, and another green section down here where we added code. So in this first one, we defined a couple of wires. One was blink, which we will use. The other is blink 2, which we are not using, so I just tied it to a 0. I used that when I was connecting up to both for another experiment. Um, let's see, then we cruise on down right here, this area, and this is straight from the user guide, the instruction tutorial. Basically, we are connecting blink up and setting it to be an output signal of cape, which would then get to an output pin of the FPGA, which would then light up the LED. Yeah. And then the last change that we made is in we instantiated Servant. And just to touch on Servant, it is a wrapper around the Serve CPU core. It contains things like some block memory for programs and data executables. It contains like a timer. It contains GPIO bit, some logic for that, some essentially some glue logic around the core. So that's all we did on Cape. Um, then okay, and then what we're going to do is now we're going to start and we're going to hack the serve code just a little bit. And so in Servant, which is essentially the top level block, um, this is the path to it from the workspace area. And we're going to replace Zephyr Hello.hex, which is the executable program to run the Zephyr operating system. It's a real-time small operating system. They have a Hello program. And we're going to replace that and run Blinky instead. Um, and let's see. And then we also have to replace um, default net list type, and I'm going to comment that out. So I'm going to put a couple slashes there, forward slashes in front of it. And I'm going to do that for all of the serve files. This is kind of an interesting command. So it's a finds, so that's finds from, it's not going to work. Is that going to work? Yeah, that's going to work. Okay, so it's going to find um, starting from Fuse SOC libraries serve, and underneath that tree, the directories, that directory tree, you'll find all the Verilog files, and it'll return them to the command line, where then the set's going to replace this with a commented version of this. The pound signs are just delimiters. You could probably use almost any character you want. Very often people use the slashes, the forward slashes, as delimiters, but then we'd be having delimiters fighting the actual things that we're trying to replace. So I just, instead of using a slash for delimiters, I use the pound key, the pound sign. And so that should get rid of all these default net types. Here is a blurb on this FPGA Wars webpage where they're talking about why they want people to have this default net type of none. Probably a good idea. Um, I've never used it. Um, the the gateware for the Polar Fire inside of the BeagleV Fire does not use it. And when you turn it on, it's meant to generate some errors if things aren't quite right, like things aren't being defined, and which is not necessarily a problem, but this guy says it could be a very dangerous problem. I'm not going to worry about it too much. And so anyway, I'm going to comment all of these out because it was causing an issue and causing failures. All right, so where are we? Back to this. We have compared, we have shown you everything that we're going to be doing. So now, with any luck, we should be able to, let's source it. Dot, go up and BeagleV build. Okay, we're going to source that build script that we just reviewed. And it should, so it's running here. It should end up creating a file structure that we can check in and push to the GitLab server, which will automatically kick off a build. All right, so it just did that. Before we leave here, I just want to just show you, just so you get a little familiarity and comfort with it. Alias Verilator Blinky. So I created a few alias that make it a little simpler, but right here is what the alias is. And you can actually run this. And what this does is it runs the Verilog test bench, which will kind of emulate Blinky. So let's hit a return and see what happens with this guy. So here it's compiling and it's running. It's running a simulation instead of in real time. It's supposed to blink every second. So in simulation time, it takes longer to actually run that. So it's like every few seconds or so. And so right here, so you can see output Q on is on. And so now it's running. If you do not have Verilator installed on your computer, if you're using Ubuntu, it's really simple. It's just a sudo apt-get install Verilator. And similar sudo apt-get install iVerilog if you wanted to do Icarus Verilog, which is also a very, very sweet open source simulator. So you can see here that the thing is toggling, which means that it's kind of working. Okay, we're going to do a Control C to stop this. I believe we've done everything that we need to do. Let's do a PWD. Once again, we are in the SERVs workspace. And now we want to go all the way back up to the top of our Gateware. So we'll do a CD ... We'll do a PWD, LS. And so right here, this right here is where our serve workspace is. And we should have copied things into our sources and maybe the custom FPGA design. So I'm expecting to see that we did things there. So now I'm going to do a git status. And that should show us what was changed. And so it says that we modified this. So git diff of the YAML file. And we expected Verilog, template or something like that to be changed to something with my serve cape. So you can see right here, we had Verilog tutorial change to my serve cape. And that's what we expected, so that's in good shape. That's the YAML file. Also, we ended up see, there's a serve auto setup, which is all the serve stuff. We will not check that in. And then we have the sources area all the way down. We have a new my serve cape folder with a bunch of things in it. So let's just do a find of that folder, which will show everything that we've added in that folder. All right, so we have a lot of serve files that you can see. Servon, Servile, Serve, And these are like all Verilog files. They're all in the MyServ Cape HDL, and then subfolders of that. We've got um, add cape there. We did some edits to that, so let's see if those actually worked. So git diff return. Really? Why is there no change to that? Cat. More. So we have all of these files here. Um, well, hmm, okay. Well, these are all the changes that we did want in this file, so I'm not going to complain too much about it. So git status one more time. So I think we're doing good, so we're going to do a git add. I'm going to add the YAML. Oh, I know why. Because it's a brand new file. That's why it didn't show. But the edits were right. Um, okay, so that's all good. We're going to do this. Now we're going to do a git status one more time. And now you can see that all of these files were added. Yeah, and let's do a git log for a second here. Right. And so this is somebody, these are things that were committed on the previous, on the on the main fork, on the main branch or the main, I don't know, repo. So now we're going to do a git commit dash m is for message, and we give it a message of add serve risk the processor to Gateware. To Cape Gateware. All right, hit return. All right, and get status one more time. And it says that we are ahead of the main by one commit, which makes perfectly good sense. Again, we did not commit the original, any of the serve, but we've copied everything we need to into the source tree for the Gateware serve on fire build repo. So now we should be able to git push, and that should kick off the build process. Ready, ready, ready. Let's do it. All right, so it's just done that. That's awesome. Now let's go back and open up our browser again. Let's go to Busted Wing. I'm gonna hit a reload. If I needed that or not. We should be able to go to hover over build right here on the left side. Slide over. Oops. Slide. Oops. Oh, what's going on? Oh, so we'll click. All right, let's click on build. That'll open the pipeline down. And we're here, and then click on pipelines. And this shows what we're doing. In that the check-in commit was add risk, serve risk processor to Cape Gateware. That's good. It's running, and the downloads artifacts are not ready yet. So this running will probably take about maybe 10 minutes, 10 minutes. And then we will and click on this down arrow, get the archive over to our laptop, and then SCP that archive, the bit stream to the Beagle Fire, and then we can run a script on the Beagle Fire, which should install um, which should install and reboot with the blinky going from SERV. All right, so now what I'm going to do is I'm going to start setting up while this is running. Oh, no, 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 no. It failed. All right, let's see if we can figure this out. Sometimes the messages are good enough, so we're still going to download the archive. We're going to go to Git Bash right here. We're in downloads, ls, uh, unzip artifacts, um, and then cat of this builds log text. Does it give us anything useful? Compiler running. It tells us we need to see the SRR. Well, that's too bad. All right, we're gonna have to debug this and start again. Okay, I think I found the bug in my build script. I updated and pushed the build script, and I'm running again. And while I'm running, let's see if we can hook up the little Beagle board, the BeagleV Fire. There we go. Connecting to the USB-C. All right. Let's open up Dev. What? Manager. Okay. Let's look at the ports. It takes a little while for it to boot. And so you won't see the COM port come up for about a minute or so. And that's what's happening right now is I'm waiting for the COM port. And that should show up right about here. Maybe that's coming. Oh, go on, don't be shy. COM port 19. So now what we're going to do is we're going to open up PuTTY. And then here we are on PuTTY. We want to go to serial port, COM port 19, which we got from right there. I like to run at 115200. And let's open. All right, it's not so bad. It's pretty encouraging. It's always nice to see. So let's log in. So they've got the login name is Beagle temp pwd is the password. So let's log in. Okay, so we're logging in. And another very important piece of information is right here. This is the IP address. And so while we're here, though, ls, I'm going to delete my custom design, which was the last, which was the last build that we put on here. Okay, so ls. All right, and also we have on this side, maybe I'm using build script too much, but this is what we're going to run on the BeagleV Fire once we've copied over my design. Okay. And so this is the address which we will SCP2. SCP2. So remember that. Something 7 is the last one. Still running. So we're going to go and set up while we're waiting there. We are going to be, it's clear. We're at PWD. We're in my home. So a CD tilde slash downloads. Everything is like case insensitive on the Windows world. with git bash and things like that. So here we are. We're doing ls. Let's remove -rf gateware tester and artifacts.zip. So everything is cleaned and ready to go for when we do our when this finishes. Oh, is there any other steps that I need to do? I don't believe so. Yeah, I think I'm going to shut it down and wait until the run is finished, and then we start up with the next phase to wrap this up with any luck. Okay, so it just finished. It passed this time. So we're going to go over here, left click on the download artifacts button, go over to build job archives, left click on that, and that will download the artifacts into our download folder, which, it's right here. Good downloads. There it is. But we're going to be using git bash to do the work with it. Okay, so here we are in downloads, which was pretty much empty before. And now you can see that artifacts is there. So what we want to do is unzip artifacts. And let's see, we want to CD down to bitstreams. So CD to Gateware builds tester artifacts bitstream, pwd ls, and then we want to scp -r for recursive, my custom FPGA design, to Beagle, the username on the BeagleBone at what was the path? What was the path? Remember? Let's go back to PuTTY. 172.16.07. 172.16.07. .0.7. So this will change, of course, depending on your network. Colon, I think. Return. All right, what's the password? We all know what that is. TEMBPWD. Turn. Oh yeah. So there it goes. So it is now over. Last stage. Com PuTTY. Make this big. Let's see. LS. So right here, you can see like before we had these files, and now after the SCP, we have this directory. Find this. Find. Make. So this is all the stuff that's in here, and cat build script. So this is what I need to run. So stop it. Let's say Control C. Let's clear this guy. Let's try again. All right. So and when I'm in PuTTY, I do a right click to paste. Okay, so sudo apt-get. Let's see, actually, tab here. Something's not right with this. So I'm going to do a Control C. I'm going to sudo /user share Beagle Gate changes I don't understand. Okay, sudo Control A to get to the beginning of the line. Control E to get to the end of the line. My design. That's harder than it should be. Hit return. Fingers crossed. This is it. Uh, TEMPPWD. All right, so it's running. So the script is running. It's reloading its flash memory or whatever. I don't know, internal memory or external. I guess probably internal memory of some sorts. And so it's loading it. When it's done, this putty session will crash because it's going to be rebooting. And when it's rebooting, then hopefully we get some action on the LED blinking, maybe about one blink per second, give or take a little bit. Um, okay, what's going on? Oh, there it goes. Good. Took a little moment, but here it is. It's shut down here, which is what we expected. So now we're going to close this putty session down. Um, and in a moment, give it a moment. We should see. Let's see if we can start an SSH. See. Okay, so I'm dancing on the lights. Let's go to putty. Serial 19 115 200 serial. It's not open. It's not supported yet. I wonder if I bricked it. It's always my fear. Maybe I bricked it. Maybe this is the time when I bricked it. Um, yeah, LEDs are not behaving quite right. Um, I should be able to COM port 19, serial 19, 115, 200, open. Okay, so it's not bricked. So putty's still working. So for the most part, we're in good shape. We can live to fight another day. But nothing's happening on our blinky lights. So my bet is that somehow I do not have the path correct for for the where the hex files are located. All right, take a break for now. Okay, so we failed last time. It actually built, but it did not run. It did not blink. I'm suspecting that the path to the hex file is not correct. I'm not quite sure on where to put the hex file so that readmemh can find it. Um, Usually it's like in the project folder where the prjx file would be. Um, I thought that's where I had put it, but I'm not quite sure with this build methodology. We'll look into that later. But I found this app note on the micro semi site talking about inferring ROM as LS RAM using a case statement. So I'm going to implement this structure in the I'm going to implement this in the RAM file for Servant. So let's copy that and swirl, 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 left, right, left. We want to go to here. We want to go down to CD dollar workspace. Let's see, actually SERV BWD LS Servant LS. All right, and let's edit serve underscore, I think, ram dot b. Let's give that a shot. All right. So this seemed to fail, right? Paste. So we're going to do a different approach. So we'll write an always block. Okay, I'm happy with that. Case statement. Indent. Okay, we're not fully ready to do this yet. I'm going to save what we've done so far. We're going to quit out of this. We're going to do a cat of dollar. Let's see. Serve slash software slash blinky.x. So this is the file that we wanted to read memh in. So we're going to copy this. We're going to go back over to, I guess we were editing, right? So let's edit this back up. Let's edit this file. Let's go down here. Boom, boom. Edit, paste. All right, so we're happy with that. Let's see. So really, we're going to have let's see what we can do here. Let's select all the way over to this. You'll see it. Now then, down. Let's see. We're gonna do a Control V, Control A to go back to the beginning of the line. Control down arrow. That's 3. So Alt R3 should repeat the last 3. It's not bad. Now then, we want to increment the address. Escape by NCR. That's not bad. Data out, Control H. Data out should really be OWB RDT. So we just did that. Quit. Control H. Data out. OWB RDT. Yes. Okay, Good as that. The 20 tick B was really a 32 tick H. 20 tick B is 32 tick H. Okay. And then we want to tab, get them all, and case, and always. Okay. Okay, semi down, alt R2. Put a semi on every line. Here, usually want a default colon. We want it to be this middle click. With that, always begin. All right. I think that's the program. Well, this guy wasn't working. Don't want him to mess us up, so I'm going to comment him out. CC. So that comments him out. Control S. Fingers crossed. Let's do Control X, Control Q. Get out. Now let's CD to the dollar workspace. And let's run Verilator Blinky. Got some syntax errors. Of course we do. Can't find a clock. Okay. On line 39. Let's see. Dollar serves as servant slash random v line 39. So Control G 39. Okay, Alt N shows the line numbers. Clock is really IWV clock. Whoops. This guy here should be Alt CC to comment out because they're being driven by this. No, S Q. Airline Blinky. Not again. It doesn't like my case statement. Expects 12 bits on the case, but 10. All right, fine. Be that way. Let's Control H, 10 tick, 12 tick. Yes. Control SQ. Verilator Blinky. Oh, let's see what it runs. So if you can simulate before you go out to hardware, you're always in a much better position. I'm ready for it now. Whenever you're ready. Come on. Hey, look at that. So that's working. It's great news. I don't completely believe it though, do you? Um, let's do one more thing. There's some potential. Let's see. Um, alias. What happens? We run this. We don't specify the firmware because we've hard coded it, and we make the memory size equal to 8192, which is kind of what I think I want it to be. What? 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 Huh. I'm not really sure on what they're trying to tell me here. Case expression generates 11. I think we actually have to pay attention to what's going on here now. Line 41. Control D, Control F. AW minus 3. Oh. I changed the width of the memory from 16K to 8K. It's a little temperamental. I don't like that. But okay, Control H. At least we understand why it happened now. 12, tick D. 11, tick D. Yeah. International queue. Around this guy again. And hopefully, if this runs, that means we're not having the test bench reach down into the design and change the memory contents, and we'll be using what is built in. Um, so we don't need to have a file. So we don't need to know where's Control C. So now then, what we're going to do is we've just validated it, so we can run the build script again, which is / Beagle build. Why are you hating on me? Oh, you're going back and forth, are you? Let's fix the script. Maybe this is the alias. So we're going to take this line here, and we're going to add Beagle build. Okay, so I'm tweaking the build script. All right, move on. All right. Let's push. Let's get this so we don't lose it. Get. Totally useless comment. Um, look at the status. Get add dash u, which adds everything that's been got the modified label like and adds all those files. Um, and then to what? It's good enough. Good push. Let's try this again. Okay, it's running. So I'll shut down, and then when this is done, we will do it again. Okay. Looks like it passed. Great news. Let's download the artifacts. Okay. Go to Git Bash. CD dollar. No, CD tilde slash downloads. rm-rf. This guy and this guy. Git unzip this guy. All right, CD to bitstreams. All right. Let's see. History. Grab SCP. Enter. Okay. Password. GE. BWD. Hmm. All right. Unless I don't quite feel comfortable about. Uh-oh. Okay. We'll do another copy over. SCP. Maybe I get the right password right. There we go. Okay, we got the password done. It's back over to here. Now we've got that. And then the cat build. So sudo / user share beagle gate change sh dot / my enter password te. All right, it's running again. I mean, it's booting or it's loading the image, and if all goes well, in a minute we'll lose screen here, and then we'll start seeing a blinky. It's not entirely satisfactory. We've got to get the read memh to work. But, for now we have a cheat that allows us to run the SERV RISC-V processor on the BeagleV Fire. Okay, so we've lost contact here. Let's give it a couple, like a minute or two, maybe a minute. I'm watching the LED, hoping something happens. We can watch here to see when the boot is done. We should start getting like maybe a COM 19 back. Some lights are kind of going kind of funny. Oh my goodness. Guess what? I have got a blinky. Yeah, man, this is going. So let's just get a quick shot of that if we can on our camera. It's worth getting. So go to photos. I'm no photo exemplary guy, but you. um, There we go. Camera. Let's see.